Hello, welcome. Today, let's try to solve another lead code problem, 2861. So this is from the weekly test, and this is the code when I was writing in the weekly contest. So let me first explain the problem, because yeah, instead of talking about what kind of a method I used, I think it's more important to talk about the problem. Because this problem normally, if you are not have the background about how to make an alloy, you maybe not understand the descriptions about the problem. Yeah, but luckily for me, I was major in material science, and my daily job is about how to make an alloy. Yeah, so this is for me why it's really easy for me to understand about the problem. So yeah, let me explain the problem first and then try to explain my method. Actually, I used this method for like more than 20 problems in LeetCode. And normally, for this kind of question, it will always be addressed in the third problem of a weekly test. Yeah. As we can see for this week, it is also the third problem. Because for the third problem, actually, it is much harder than the second and the first problem. Yeah. Now let's try to understand this question. Yeah. We don't understand it because there are so many variables. Yeah. When a problem gives us 2 or 3 variables, it is easy to understand. But for this problem, it gives us 6 variables: N, K, budget, composition, and stock, and the last one cost. So there are so many variables. If we are going to use the algorithm, how can we consider all the variables? It's really difficult to think about it. Yeah, so this is why even we understand the problem, we cannot turn this problem into our template directly. I mean, into the binary search template directly. Yeah. Basically, for this n means how many compare. Yeah, this n means how many numbers of the alloy we have, the compositions of the alloy we have. For example, inside it is 1, 1, 1. So this n means the length of the composition. Yeah, but not the length of the composition, but inside it means the length of the cost array. Yeah. So for this problem, even it didn't give us this n, we can still solve it. We can use the length of the cost array. Yeah, because cost is for each of the cost of the alloy. Yeah. And so the length of the cost is this number n. And what about this k? I didn't even use this k. Yeah. Let's check this k. K is about how many machines we have. Yeah, you have access to k machines that can be used to create alloy. Yeah. So it gives us k machines. So for each machine, it will make alloy. So how the machine will make the alloy? It will use this kind of composition. So this is for the first machine, and the second one inside of the composition array is for the second machine. Yeah. So all alloys must be created with the same machine. Yeah. So there are it is so much confusion, but it is still does matter if we read the question. Yeah, each machine requires a specific amount of each metal type to create an alloy. Yeah. So if you don't have the background, you are not major in this area, so basically it is quite confusing. Yeah. Now we have to turn this problem into the algorithm. Yeah. So the composition, as we already know, there are 2 different kind of alloy. So the first alloy, the composition is the first array. For the second alloy, the composition is the second array. Yeah. And this cost is for each element inside this composition. For example, for the first one, it is 1, 1, 1. So the cost is 1, 2, and 3. And we also have a budget. So we should use we should use the money, use the cost less than or equal to the budget. Yeah. Yeah, so this is why we can use binary search, like binary search to search the answer for solving the problem. So basically for the binary search template is to use binary search to guess an answer. Yeah, so how can we use binary search to guess an answer? Normally we need to have a lower value and a higher value. So the lowest value and with the highest value. Yeah, so this is in the contest I prepared the R to 10 to the power of 8. It didn't pass. Yeah, because when I checked it is too small actually. So I give a random value. I give it very large, like 10 to the power of 14. Now let's check this maximum value can be what? Yeah, so the lowest value, if we are going to make an alloy, it cannot even be 0, but it doesn't matter. Yeah, because in the contest I don't have enough time to calculate what is exactly the lowest, what is exactly the highest value. But definitely, I'm sure I can use a binary search to find my answer. Yeah. Now let's check what can be the lowest and what can be the highest value for L and R. So we are going to calculate the uh, yeah let's check the return maximum number of alloys that the company can create. Yeah. Yeah, I solved it and now I even forget the problem. Yeah, it means that there's so much information. Yeah. Uh, so the cost. Yeah, let me check why I did it like this. Uh, yeah, we are going to return the maximum of alloy we can make. Yeah, so we need to check the composition array one by one to check which composition can make the alloy maximum. So inside this example, we can check like this. So for the for this example 2, for the first one, it is 1, 1, 1. So we can use a 5 unit of mantle of the first type, 5 unit of mantle of the second type, and 0. Yeah, because we are going to use the second array, not the first. Yeah. Yeah, because why? We are going to use the first array, not the second. But we have a stock of 100. It means we don't need to buy for the third element. We only need to take cost for the first and the second element. Yeah. So as you can see here, 5 times 1 plus 5 times 2. So 2 is the cost, and 1 is the cost of the first element. Yeah, we just need 5. So we're gonna return a 5 because this value equals to 15. 15 is less than and equal to the budget. So this is why we can get an answer of 5. But you cannot make an answer of 6. If it is 6, so this result will be 6 times 1 plus 6 times 2, it will be 18. 18 will be more than 15. So this is why 5 is the maximum result. Yeah. And let me say what to check. Yeah, as I explained earlier, so basically for using binary search, I need to have a result. So this result is my final result. Yeah, but for each of the result, I need to check which answer is the maximum. So for here, I use a result. Need to check this answer. If it is more than this result, I will put it inside my result. After that, I'm gonna return this result. Yeah, but for this answer inside, this is for binary search. We did so many binary search with answer problem, but there's no for loop. So for this problem, it is a little bit harder. Not only about the problem is so confusing. It's also about there is still a loop, for loop inside, outside the binary search. Yeah. So inside the for loop, basically it is a binary search. Yeah, basically for me, I use the L and R to 0 and 10 times 10 to the power of 14. So the answers I can give it as 0 or any answers it doesn't matter because the final answer will be updated and the final result will also be updated. And for here, this is basically the template for binary search. So here, there's a little bit different. So if check MC, so M is my value. It means the alloy. What is the maximum of alloy I need? Yeah, so this M means how many alloys I can make. Use this compare use the combination of the element with the cost lower than the budget. Yeah. So this M is the value, maximum number of alloys I can make. And this C is actually inside the composition. It means one of the compositions. For example, I will make the first one first to check what is the maximum value, and then the second one. And I will get the final result will be the maximum of all the answers. Yeah. But inside, this is basically template L and less than or equal to R, and this is M because this is a binary search, and this is the tag. For this tag, if it is an answer, yeah, it means why not we guess a bigger number. For example, for this example, if we guess a number, it is 1. Yeah, if we can make one alloy, but our budget maybe just yeah, I just guess a random number, maybe 1 plus 2, 3. 3 is less than 15. Yeah, it means we can make more alloy. So the L pointer should be updated to M plus 1. But before that, we need to give an answer. Yeah, our answer should equal to M. And then L should equal to M plus 1 because we need to check a bigger value. Maybe the next value for M would be 5. And then we get our result for the 5. Yeah. So this is for analyzing of the problem. Basically, I also mentioned about this L pointer and R pointer, but we didn't check. Now I think I have enough time to check what exactly the L and R can be. Yeah. For checking the L and R, we need to check the array of this C. So this C is inside the composition. Yeah. If we are going to make an alloy, so what about this composition array? Let's check the composition array. So inside the composition array, the length is n. Yeah. And composition, the length of the composition is k. And composition I is n. So it is exactly told us. Yeah, so this is why we don't even need to use this k and n. If you are using Python or any other languages, you don't need to have, yeah, you don't even need to use this value. At least for Python, I don't need to use this k and n because I know exactly what it is. And let's now check the composition I and z. As we already know, this I and z, it is more than and equal to 100 and less than and equal to 100. So this is why this is so important. So in the context, I didn't use this result because I'm sure I can get the final result because of the binary search. Now we have this composition. The smallest value is 1. Yeah. If the smallest value is 1, so what the L can be? So this L, the smallest can be 1 because if the array, if this, let me check. Yeah. So if this n equals to 1, so the smallest value for this n is 1. So if the composition I dot less equals to 1, and the value is exactly 1, so it means the smallest value is 1. So what about the biggest value? The biggest value should be 100 because maximum number inside is 100. And what is the yeah, so what is the length of yeah, the stock I, let me check the, yeah, we have to check the cost array. So yeah, let me check the maximum value. So the maximum result should be cost stock I. Yeah, let me check the maximum result. So the cost I, the maximum is 100. And the maximum alloy we can make, let's check the maximum alloy we can make. It is dependent on this number inside, I believe. So this number is stock I. Yeah, let's check the, yeah, so the cost, we have a cost, but we also have a stock. So the maximum alloy is dependent on the stock. Yeah, if we have a maximum of stock for its value, stock I is 10 to the power of 8. Yeah, if for each alloy, we just need composition 1. Yeah, so this, the maximum alloy we can make is yeah, according to this cost array inside is 10 to the power of 8. Yeah, I used the 10 to the power of 8, but it didn't pass. I believe it should be a bigger number, so I give it 10 and to the power of 14 because I think it's big enough to solve the problem. Now let me check the maximum value for this R. Yeah, it depended on the composition array. And let's check. The composition is 100. Yeah, but we can make this value even bigger. Composition IZ, this value. Yeah, if the composition I and Z equals to 1, and let's now check about budget. Yes, it is dependent on the budget. If the budget is 10 to the power of 8, and the composition IZ uses the smallest value, it is 1. Yeah, so basically the maximum should be 10 to the power of 8, but we also have the stock. What if the stock is 10 to the power of 8? Yeah, so this means the maximum alloy we can make, actually it can be 10 to the power of 16. Yeah, for example, we have a stock of 10 to the power of 8. Yeah, and we inside, for making the alloy, we only need one element. And the composition I and Z, this value is only 1. So it means the maximum value can be 10 to the power of 16. But inside the LeetCode testing cases, it didn't give me this value. Yeah, if the LeetCode give a bigger value, maybe this cannot pass. So I have to use 10 times 10 to the power of 16. Yeah, because it is unlimited, I think the result is unlimited. I mean, if this array, there is only one element, it is 1, and we have a stock for the element, it is 10 to the power of 8. Yeah, it means we can at least make 10 to the power of 8 alloys. Yeah, now we can plus our budget, because our budget is 10 to the power of 8. So this is why the result should be, the R pointer should be 10 to the power of 16. Normally, only for this it can pass. Yeah, now let me just run it to check if it works. Yeah, in the contest I used 14. Actually, it is not right, but it can pass for the LeetCode because LeetCode didn't prepare the biggest value according to the design of the problem. Now let me submit it first. Yeah, after that I will analyze the check function. Yeah, so the check function is also a little bit harder than the usual binary search. Yeah, but if you understand the question, you know how to use the binary search. Normally, this check function is not so difficult to analyze. Yeah. Now, as you can see, 10 to the power of 16 works, but when I use the 10 to the power of 14, it still works. That doesn't mean it is technically speaking, this is not right. I believe according to the design of the problem, but LeetCode didn't have the testing cases for this one. As you can see, this one also passed. Yeah, but what if I use a smaller value, maybe 10 to the power of 10? Let's see if I can pass or not. Yeah. Yeah, let's try to use the 10 to the power of 10. So for this value, it still can pass. Yeah, let me prepare 10 to the power of 8. It cannot pass. Yeah, as you can see, it cannot pass. So this is exactly what I did during the contest. Now I at that time I believe I didn't give a big value enough, but I cannot even see this budget. Yeah, because during the contest I cannot see this kind of information, so I have to guess it. So this is not likely when you are doing the practice. So the practice environment is different from the contest environment. So during contest you cannot see that. Yeah, you should know about it. So this is why you need a lot of practice to get familiar with the question. Yeah. Now let's try to use the 10 to the power of 9. Yeah. Yeah, 10 to the power of 9, they still let it pass. Yeah, now let me analyze this biggest alloy it can be. Yeah, so as you know, inside this composition, if there's only one element, this element is 1, and we have a stock. So the stock's maximum value, stock I, is 10 to the power of 8. Yeah. Yeah, it means we don't even to take any money. We already have this kind of a stock. We can already make 10 to the power of 8 alloys. So, and then plus the budget, we can make even more alloy. Yeah. So basically, 10 to the power of 9 can pass. Yeah, basically, I think this would design more testing cases to avoid this kind of a situation. Basically, yeah, because actually we can make the maximum alloy of 10 to the power of 16. Let me check more about it. So because this is a budget and this is a stock. Yeah, we already have the stock. Now we can use this budget to make more alloy. Yeah, because the alloy array, this K and N, minimum can be 1. This is why. Yeah, but even I prepare 10 to the power of 9, it can pass. Normally it should not pass. Yeah, maybe they didn't consider about it. They just give a value big enough and let you pass. Now let me analyze the check function. So if you already did some work in these areas, you've already written this code. Normally this one should not be so difficult because you've already think about how to use the binary search a value template to solve the problem. Yeah. So this is for needed. I prepare a needed array. So needed array is inside the composition array. So for example, inside this array. Yeah. So when inside this array, so this is the C. C is the composition for this array, subarray, and the threshold is my guess. I will guess a value. So now it becomes easier because we can just use the needed array. Yeah, if I have no stock, if the stock is 0, yeah, from the beginning, so the needed is I times the threshold. Yeah, for example, the threshold is 5. So inside this value, 1 times 5. So for I in C, inside this array. Yeah. And then I updated the needed with the stock. Yeah, because if I have stock, I don't need to have so many elements. For example, for this one, for the last one, I have a stock of 100. So I will use needed I. So inside my needed array, I will minus stock I. So the first one will minus 0, and then the second one will minus 0. But for the third one, if my guessed value is 5, so 5 times the threshold. For example, use the second example. For example, this one, 5 times 10 is 50, right? Yeah, so this is 50, but I've already have 100 stock. So 50 minus 100, it is a minus value. So this is why, I will first explain the needed minus stock area, because needed minus stock just need to get the final needed value for making the alloy. So the needed I should, let me prepare an array to make it more easily to understand. So for the, I will use this one, I will use the second array, this one, as an example. Because, let me check. The first one, the second one. So this is uses the second machine to create alloys. So to create 5 alloys, we need 5 units of the first type, 5 units of the second type, and 0 of the third type, because we have the stock. So in total, we can make 5 times 1 plus 5 times 2 equals to 15 coils, which is smaller than or equal to the budget. So let me use this example. So inside we have this kind of array 1, 1, and 10. Now I will use I times this threshold. So my threshold is my guess is 5. So after 5 times every element inside, it becomes 5, 5, and 50. Now for the second array, I used a cost to represent how much money I need. If the cost is less than or equal to budget, it means the check function is true. If it is more than budget, it means the check function is false. So for the second array, I'm going to check the needed. So and here is needed. I've already let me. So the first needed is without considering the stock is from here. So the second needed actually it is considering the stock. So it is needed I. This 5 minus the stock I. It is 0. 5 minus 0 and 5 minus 0 and 50 minus 100. So it is a minus 50. So this is the second needed. And the third one is the cost. So the cost is the sum of those values. Actually it is the budget. If this costs is less than or equal to budget, it means the final result is true. So this is the needed I times the cost I. So the needed I is this one, 5 times the cost I. So the cost I is 1. In this example, it is a 1. Let me copy the cost here. So this is the cost, and this is the needed. So it means this value 5 times 1. My final result would be 5 times 1 would be 5. The second value would be 5 times 2. It would be 10. And what about the third value? So for the third value, it is a 50. So this is a minus 50. If it is a minus value, it means we have enough stock. We don't need it even to take actual cost because we have enough stock. Yeah, it is a minus value because this means we don't need alloy for the third element. Yeah, so this is why I added a tag. So if this needed I is more than 0, I would to put it inside my array. Yeah, so if this value minus 50 times 3 is a minus value, it is minus 150, so I will not put it inside my array. So this is why inside my array is only 5 and 10, so sum of them is 15. So 15 is less than and equal to the budget because the budget is 15. This is why I can use binary search to get the final result. It is this app. Yeah, I hope you understand the question. Basically, I explained a lot about how I solved this problem from the beginning. Yeah, and how I understand it and how I can apply it into binary search. And for the algorithm, actually, this is a very easy algorithm to apply. Yeah, just use a binary search and to prepare a tag function. Yeah, but it's really difficult to think about it, especially for this problem. Yeah, up to now, I think this problem is a little bit harder than other binary search template problems. Yeah, and now let me analyze the time complexity. Yeah, so I also checked with this n and k because it is just 100. Even I have a for loop, I didn't add. I didn't make it too slow. Yeah, because inside the compositions for this one, for this for loop, I need to check the composition array. The length of it is k. K is 100. So from here, it is 100. Yeah, 100 times a binary search. So here, basically, I use the binary search. Yeah, and inside a binary search, let me analyze the time complexity a little bit. 100 times this binary search, and for binary search we need to loop through the array. So the length of the alloy, let's check, it is also length of the alloy. Let's check the composition I dot length is n. It is also 100. So from here it is n times k, n times k, and times, because inside it is a binary search, the final one. So for this binary search, it is according to the smallest value and biggest value. Yeah. As I already explained earlier, so this one actually should be 10 to the power of 16 according to the problem. Yeah. Even they didn't prepare the testing case like that, but I still believe it should be 10 to the power of 16. So for this one, it is log 10 to the power of 16. Yeah. Even it is 10 to the power of 16, but for a log, it is not a big number. Yeah, this may be just less than 50, or maybe 50 or 60. Yeah, so 60 times 10,000. So this is why it is like 50 times 10 to the power of 4. Yeah, this is why it can pass for the LeetCode. Yeah, maybe this value is bigger, maybe 70, but it should be less than 100 for this number. Yeah. So it seems like 7 times 10 to the power of 5. So this is why we can pass for the LeetCode. Yeah. Thank you for watching today. See you next time.